Hello again. In the previous example, we have looked at how to determine empirical and molecular formulas from mass percentages. But this is slightly challenging. Here you don't have the actual masses of the elements given to you, but you have some combustion data, the mass of carbon dioxide and water that is given when a given sample of a compound is combusted. So we have to use this combustion data to determine the empirical and molecular formula. So the first step is we need to calculate the mass of carbon, oxygen, hydrogen, because it says this compound is made of 3 elements. So we need to determine the mass of carbon, hydrogen, and oxygen from the masses of carbon dioxide and water. So let's start with carbon. So 1 mole of carbon dioxide, which is about 44 grams per mole, contains 1 mole of carbon, which is about 12 grams per mole of carbon, right? So 1 mole of carbon dioxide contains 1 mole of carbon, which is 12 grams per mole. But in the problem we have 1.866 grams of carbon dioxide. That would contain how much of carbon? Let's call it X. So you can calculate X, or the mass of carbon, as if you cross multiply that, that would give you about 0.5089 grams of carbon. Similarly, 1 mole of water, 18.02 gram per mole, contains 2 moles of water, which is 2.1 gram per mole. So in the problem I don't have 18.02 grams, but I have 0.7639 grams. So 0.7639 gram of water contains how many grams of hydrogen? Let's call that X. So if you calculate for X, that would be 0.08563 gram of hydrogen. Similarly, let me write this here for oxygen. Right? Now, to determine the mass of oxygen, we have to add up the masses of carbon, hydrogen, and subtract it from the total mass of the compound. So the total mass of the compound is 0.821 grams minus the mass of carbon, which is 0.5089 gram, plus the mass of hydrogen, which is 0.08563 grams. So if you do that, you will be getting about 0.2265 grams of oxygen. So now we have determined the mass of carbon, hydrogen, oxygen from the mass of carbon dioxide and water. Now the rest of the method is very similar to what you have seen in the previous example. So we take these masses of the elements and convert them to moles by dividing the molar masses. So the molar mass of carbon is 12, the molar mass of hydrogen is 1.01 gram per mole, and the molar mass of oxygen is 16. So as a result, we get the moles of carbon would be 0.0424 moles carbon. Hydrogen would be about 0.0848 mole of hydrogen, and oxygen would be 0.0142 mole of oxygen. So now we have the moles of carbon, hydrogen, oxygen. But to determine the empirical formula, we have to arrive at a simple ratio. So this is how we calculate the simple ratio. So we divide each of these moles by the smallest number here, which is 0.0142. So I divide that by 0.0142, this by 0.0142 and that by 0.0142. So as a result, I get my simple ratio would be, now here you can round off these values. So let's say I get 2.98 mole of carbon and 5.97 mole of hydrogen, and this would be 1 mole of oxygen. So I'm allowed to round off these values. The simple mole ratio here, I can round that to 3 mole of carbon, 6 mole of hydrogen, and of course 1 mole of oxygen. So my empirical formula would now be, that is C3, excuse me, let's go a little bit down here, that's annoying. Alright, so my empirical formula would be C3H6 and O. That's my empirical formula. Now we need to calculate the molecular formula for this. So we take the given molar mass, or sorry, molecular mass. Molecular mass is basically the mass of one molecule, which is 116 atomic mass units, divided by the empirical formula weight, which is about 58. So if you consider that as 1 unit, you can also basically call that as atomic mass unit. So this would be 2. So to get my molecular formula, I can take this value and multiply the empirical formula throughout with this number 2. So that would give me C6H12 and O2. That is my molecular formula. Alright, so that is how we determine empirical and molecular formula from the combustion data, and that completes this video.